Why is duty cycle crucial for DC-DC converter efficiency? Imagine you're trying to control how much energy flows through a circuit with a simple switch. That switch turns on and off rapidly, and how long it stays on is what we call the duty cycle. In power electronics, especially when designing DC-DC converters, this tiny timing detail makes a big difference. A duty cycle is the ratio of the time the switch is on to the total switching period. Think of it like a flickering light. If the light is on half the time, the duty cycle is 50%. If it's on for a quarter of the time, it's 25%. This ratio controls how much voltage or current gets transferred from the input to the output. For example, in a buck converter, the output voltage is directly proportional to the duty cycle. If the duty cycle is 50%, the output voltage is roughly half the input voltage. In a boost converter, the output voltage depends on the inverse of 1 minus the duty cycle. So, changing the duty cycle adjusts the voltage level. Now, why does this matter for efficiency? When the duty cycle is very low or very high, the converter tends to lose more energy. At very low duty cycles, the switch is on only briefly, which causes higher switching losses because the switch is switching on and off frequently. These losses waste energy as heat. At very high duty cycles, the switch stays on most of the time, leading to increased conduction losses because current flows through the switch longer. Both situations reduce the overall efficiency of the converter. In renewable energy systems like solar panels, efficiency is key. These systems relying on DC-DC converters to match the voltage from the panels to the battery or load. If the duty cycle isn't set correctly, energy gets lost, and less power reaches the batteries or appliances. That's why adjusting the duty cycle precisely is so important. It helps maximize the energy transfer and minimize waste. DC-DC converters can operate in different modes. Continuous conduction mode means the current flows steadily through the inductor, which usually results in higher efficiency. Discontinuous conduction mode involves the current dropping to zero during part of the cycle, which can cause more losses. The duty cycle influences which mode the converter operates in, affecting how well it performs. In summary, the duty cycle is a key factor in how well a DC-DC converter works. It controls the output voltage and impacts how much energy is lost during operation. Properly adjusting the duty cycle ensures the converter runs efficiently, which is especially important in power systems and renewable energy setups where every bit of energy counts. By fine-tuning this small but powerful parameter, engineers can make sure energy is converted with minimal waste and maximum effectiveness.